All right, we're going to have a short video here today on Chebyshev's theorem and the coefficient of variation. All right, Chebyshev's theorem is a way to set up an interval for data for a data set. It's more of a general option for a range or a spread of data, and we can see what Chebyshev's theorem says here. Chebyshev's theorem says that any data set and any k greater than 1, right? This only works for k is greater than 1, that this percent, 1 minus 1 over k squared, percent of the data is going to fall between the center, the mean of the data set, and that many standard deviations. Okay, so x bar is the mean, s is the standard deviation. We're going to use this data set here. Once we find the mean and the standard deviation, according to Chebyshev, Chebyshev was a Russian guy. If you study statistics for any length of time, you'll find out that a lot of Russians were doing work early on in the 40s and 50s at the kind of the birth of statistical analysis. So you'll see a lot of Russian names if you study statistics. So this guy Chebyshev tells us if k is 2, 1 minus 1 over 2 squared, or 1 minus 1/4, leaves us with 75% of the data will be in this interval of the mean plus and minus 2 standard deviations. 88.9% if we use 3 standard deviations, 1 minus 1 over 3 squared, and 1 minus 1 over 4 squared for 4 standard deviations. And those are usually the only levels that we're going to look at when we do Chebyshev's theorem. Now notice this is a more general view of the sort of the 68, 95, 99.7 rule, but that was for a normal distribution. That was a special case where the distribution was normal. This is for any data set. So notice the numbers are a little bit different. For 2 standard deviations in the 68, 95 was 95%. Here it's only 75%. This is an estimation. So the first thing we have to do is look at the data set and find the mean and the standard deviation. Okay, well, we know how to do that, right? Well, we'll do it one more time here on our calculator to show that. Okay. And we know we turn the calculator on, we go to our stat menu, and we're going to put this list of data in under edit. So we hit edit, and we put this data in. So 1.69, 1.69, 1.49, and again, just very carefully put these numbers in. Make sure you don't make any mistakes. It's a real pain if you miss one number, and that screws up all of your work. So 1.79 and 1.39. This is the tedious part of statistical analysis, but very important to get this right. Put in all the numbers correctly. 2.89, 1.49. 1.39, 1.49, and lastly, our 10th value of 1.99. All right, so we got all our 10 values in the list, and now we want the mean and the standard deviation. So we go to Stat menu again, we move over with the arrows to calculate, we choose one variable stats, we put the correct list in, it's L1, we hit enter, get down to calculate, and we have our one variable stat. So now we see our mean is 1.87, and our standard deviation, remember we're using the S sample standard deviation and not the population standard deviation. So the sample standard deviation, we will round to 2 decimals and say 0.62. All right, so now we have the information that we need, right? We found the mean and we found the standard deviation of our data set of 10 items. So if we want to find a 75% Chebyshev interval for this data, all we're going to do is create this interval with a k of 2. So we know the mean is 1.87. We know we're going out 2 standard deviations of 0.62. So we can say with 75% confidence that our interval, our 75% interval is going to be 187 minus 2 times 0.62, or 0.63. And if we look at the other end, we're going to get 3.11. So that is a 75% Chebyshev interval for the given data here of these 10 spots. If we wanted a 88.9% interval, the only difference is going to be 3 instead of 2. So now we would get 1.87 plus and minus 3 standard deviations. So that would be 0.01, 0.01, 0.01, and the other end is 3.73. Right, so that would be an 88.9% Chebyshev interval. Notice the lower end is lower and the higher end is higher, right? The more confidence for a confidence interval, the wider the interval has to be, right? So 88.9% interval, 3 standard deviations, 75% interval, 2 standard deviations, right? So that's how you find a Chebyshev interval. All right, so one more thing here is the coefficient of variation. Let's put this on the screen one more time. Make sure you got everything. Okay, so now we're going to look at the coefficient of variation. And this, again, we'll use the same data set here so that we can save ourselves some time calculating. But any data set given, again, we'll use this one. To find the coefficient of variation, we're going to call this the CV. Okay, so coefficient of variation, we'll call that CV. And that is just simply going to be the standard deviation over the mean, and we're going to multiply it, but we're going to get a decimal when we do that, right? The standard deviation is going to be usually smaller than the mean. We're going to get a decimal, and we're going to multiply that by 100%. So we're going to get a percentage. This is a measure of variation, similar to the standard deviation and the variance. But it gives us a little bit more of a unitless measurement, right? When we talked about standard deviation and variation, it was in the units of the data being given. This is a unitless variation formula, right? The standard deviation and the mean are going to be in the same units, so they're going to cancel out. So this is a unitless form of the spread of a data set. And that's all it's going to be. So if we want the coefficient of variation for this data set, we first need to find the mean and the standard deviation, which we've already done in this case. And then all we got to do is formulate that ratio of 0.62, the standard deviation, over the mean, and then we're going to multiply it by 100, and we're going to call it a percentage. So we plug that into our calculator, and we say 0.62 divided by 1.87. That's going to leave us with 0.332 if we round to 3 decimals. And then we're going to multiply that by 100%. We know multiplying by 100%, all we're doing is moving the decimal 2 spots to the right. So we end up with 33.2% is the coefficient of variation for this data set. So it tells us that the standard deviation is about 1/3 of the mean, and that gives us an idea of how spread out the data set is. All right, so that is Chebyshev's theorem and the coefficient of variation.